All right, so our last section for chapter 10 is on complex numbers. So these are the numbers that I was referring to in the other sections that include the imaginary unit. And the imaginary unit is I. So this is how we are going to give an answer to all of those problems, like square root of -16, where normally we just said this was not real. Now we can actually give an answer for these. And so this is kind of why mathematicians came up with imaginary units, because they don't like not having answers to questions. And so they came up with the imaginary unit so that they could give an answer. So I is defined as the square root of -1. And one other thing we're going to need here is I squared, because we'll encounter this a lot. And so if we think about squaring a square root, those cancel and we get just -1. So this stuff is really important. Put some stars around it, underline it. This stuff is really important to know. So before we get into complex numbers, we'll talk about what those are. First thing I want to do is simplify with imaginary numbers. So we're going to see some of those examples where we normally say not real. But now in this section, if you encounter one of these, you are going to put your answer in terms of I. So let's just look at some examples here. And we're just told to simplify. So when you're told to simplify, it's implied that you want to get the negative out of the radical. We do not like leaving negatives inside the radical, kind of like how we don't like having negative exponents. So number one here, we're given the square root of -16. Now I'm going to go through this one first in the kind of long way, and then what I'm basically going to end up doing with these is pretty much skipping from the first given problem to the end. So what we're going to do first is we're going to split this -16 into -1 times 16. And then using our reverse product rule, we can go ahead and split this up. So we have the square root of -1 times the square root of 16. Now we know the square root of 16 is 4. And now we know that the square root of -1 is I. So instead of writing this as I times 4, just like with variables, we're going to write this as 4I. Now, what I'll normally do is I'll go straight from this first step to this last step here. We're just going to take the square root of whatever the number is. That's 4 in this case. And if you see a negative, put an I. And sometimes I'll take the I out first and then deal with the numbers. So let's go ahead and look at another example here. So square root of -100. Again, let's look at the number first. It's a perfect square, so we don't have to break it down. So square root of 100 is 10. Square root of a negative is I, so 10I. So I'm going to skip all those middle steps. If you want to do those are perfectly fine. But I'm just going to skip straight to that one. Number 3, let's do negative square root of -81. Now remember, if you have a negative in the front, keep the negative in the front. The square root of 81 is 9, and the square root of a negative is I. So be careful on ones like these. Remember that these negatives do not cancel out. So leave that negative in the front and then treat that negative in the square root as an I. All right, number 4. Number 4, we're given the square root of -7. Now this is one where the 7 isn't a perfect square. So first thing I'm actually going to do here is take out that negative as an I, and then leave just the number on the inside. Now, If we look at this one, 7 isn't a perfect square and we can't break it down into a perfect square times another number. So this is actually as far as we can go. Always take out the negative as an I, but keep the numbers inside if you can't simplify them. Number 5, the square root of negative 32. So a couple of different ways we can do this one. We can break down the negative 32 first into a negative 1 times our perfect square, which is 16 times 2, and deal with it this way. Or you can do what I'm about to do, and I'm always going to take that negative out first if we have to do anything else with the number. So the square root of a negative is I, and then I'll leave the 32. Now we can treat the square root of 32 like we normally do. So I'm going to break this into 16 times 2. And then if you remember, the square root of 16 is going to come out in front as a 4. And so now when we bring it out in front, standard notation is to put that 4 in front of the I. So we're going to have 4I square root of 2. Okay, so now let's go ahead and try 2 more of these. These ones are a little different. These ones have I's in the given problem. So number 6, we're given 1 over I. Now, the reason why we have to simplify this is because if you think about what I represents, I is the square root of negative 1. Now remember back to section 10.5, we do not like having radicals in the denominator. So what we have to do here is rationalize. So we're going to go ahead and, if you remember rationalizing, we're going to multiply by the square root of negative 1 over the square root of negative 1. Now on the top, we just get 1 times the square root of negative 1. That's just the square root of negative 1. On the bottom, the square root of negative 1 times the square root of negative 1. Remember the shortcut here. This just gives us negative 1. And now to do a little bit of simplifying, we can't cancel these out, but the square root of negative 1 is I. So I'm going to change it back. The bottom is still negative 1, and any number divided by negative 1 is just going to flip the sign. So this is negative I. Now, the other way you could have thought about doing this, in this step right here, when we have 1 over I, instead of changing that to a radical and then going through and doing this process, you can also think about that we know that I is the square root of negative 1, so we don't want any i's in the denominator. So if I go ahead and rationalize, I can rationalize by multiplying by I over I. So on the top, we have 1 times I, which is I. Now on the bottom, I times I, just like with variables, gives us an I squared. Now you don't want to reduce this down because you just get back to what we started with. But remember from the first page here, we said that I squared was negative 1. This is why it's really important to have this fact down, because whenever we run into I squareds, we're just going to replace it with a negative 1. And we're right back at what we had here. So whichever way you want to go through this, if you want to keep it as an I or change it to a radical, both of them work perfectly fine. All right, and the last one here, we're given negative I squared. So again, we know that I squared is negative 1. And there were no parentheses around the negative and the I. So these aren't stuck together. I'll leave that negative out in front. And now I squared is negative 1. So we have negative 1, which is just 1. Again, really important that you know that this is negative 1. All right, now let's go ahead and look at multiplying imaginary numbers. Oops. So what we're actually going to be multiplying here is the radicals, not the imaginary numbers themselves. So one thing that's really important, and let me actually put this in red, is that the product rule, and so remember our product rule said that the square root of A times the square root of B is the square root of A times B. This only works for non-negative radicands. So that means that this rule does not apply to any numbers or any radicals where you have a negative on the inside. And I should also add here product rule. Let me erase that. And the quotient rule. So remember the quotient rule was where you had the square root of A over B is the square root of A over the square root of B. Okay, so what we are going to do to deal with this problem so that we can still use the product rule is we're going to change to I first. So let's take a look at what I mean by that. So we're told to multiply or divide, depending on what we're given. Number one here, we're given the square root of negative 16 times the square root of negative 4. Now, the reason why, and I wouldn't write this down just so you don't kind of look back at it later and think that that's the correct thing to do. The reason why we can't just multiply these is because if I multiply together what's on the inside, we have the square root of 16 times the square root of negative 4. Negative 16 times negative 4 is going to give us a positive 64. So we somehow end up with this real answer, and this is exactly what we would have gotten if we had the square root of positive 16 times the square root of 4. But these are different numbers. They should not give us the same answer. So we actually have to, in order to use the product rule, change these to i's first. So the 16 is a perfect square, so is 4. So I'm going to go straight to the i's. So square root of negative is I, square root of 16 is 4. So we have 4i times square root of 4 is 2, and then negative, so I. Now, if we go ahead and multiply these, think of them just like variables. So if we had 4x times 2x, we're going to multiply the coefficients. So we get 8. I times I is I squared. And now if we go ahead and remember that I squared is negative 1. So since we have 8 times I squared, we have 8 times negative 1, and 8 times negative 1 is negative 8. If we hadn't changed them to i's first, we would have gotten a positive 8 as our answer, but that would have been the exact same thing as square root of 16 times the square root of positive 4, which is not what we want. So make sure you change it to I first. Let's try another. So the square root of negative 15 times the square root of 2. Now with this one, we have a negative and we have a positive. And so we go ahead and change to I first. With this first one, I'm just going to take out the I and then leave that 15 times the square root of 2. Now, if I go ahead and multiply these radicals together, we're just going to leave that I in the front. And then we have the square root of 30 from the 15 times 2. Now, if we go ahead and try to see if we can break down this 30, we have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. None of these are a perfect square, so this is as far as we can go. So one thing I do want to point out, because you might notice it when you go through and do other problems, had I just multiplied these together, we would have gotten the square root of negative 30, which is what we got over here. Take out the negative as an I, and then you leave the 30. This is the only time that this works. If you have a negative times a negative under the radicals, you have to change them to i's. You only have one negative, you don't actually have to change it, but it's really good to stay in the habit of just taking out that negative as an I. So I don't usually like to show this way because it only applies to this one case. All right, number 3, let's go ahead and do a quotient. So the square root of negative 27 over the square root of negative 3. So again, let's go ahead and change these to i's first because we have negatives under the radicals. So first thing I'll do is just take out the I in each. And then we could simplify this down, but I'm actually going to wait until the end here. Okay, so if we go ahead and simplify the square root of 27, 27 can be broken into 9 times 3. Leave the bottom alone for now. And now the square root of 9 is 3. So we can take that out. And so now in the front of this one up here, we have a 3i square root of 3 over I square root of 3. Now, one thing you'll notice here is that we have i's on the top and the bottom, so let's cross those out. And square root of 3 that we can also cross out. So we just end up with 3. Now, this is another one where if we have a negative over a negative, we would have gotten the square root of 9. We would actually end up with what we wanted, but again, this sometimes works, but not always. So always make sure you are converting to i's and then going from there. There we go. All right, number 4, let's do one more of these. This one we're given the square root of negative 40 over the square root of 10. First things first, let's go ahead and change to I. So I'm just going to take the negative out as an I and then leave the 40 for right now. Now I'll go ahead and break up that 40 into a 4 times 10. So the square root of 4, we can take out. That's going to be a 2. And so if I go ahead and take that out, we get a 2i left with a 10 on the inside. There's a 10 in the denominator under a radical. So we don't have to rationalize for this one because these guys actually just cancel out. So we're left with 2i. All right, so those are imaginary numbers. Now let's take a look at complex numbers. And complex numbers are kind of a broader category of imaginary numbers. So imaginary numbers are contained within complex numbers. So complex numbers are of the form a plus b I. So this in the front that doesn't have the I is the real part of the number, and bi is the imaginary part. So in your complex numbers, you're going to have a real part and an imaginary part. And then there are 3 types of complex numbers. first one here, let's say I gave you 3 plus 2i. Notice how it's in the form that we're given here. This is a non-real complex number. So again, this is a specific type of complex number. This is just kind of a standard complex number. It's non-real because it has the imaginary part to it. The next type, so let's say that we had, let me backtrack here. There we go. Let's say the coefficient in front of the I was actually 0. Well, 0 times any number, real or imaginary, is 0. 3 plus 0 is just 3. Now, if you have a number like this, well, this is just a real number. What if we had a 0 in the front instead? So let's say we had 0 plus 2i. Well, this is just 2i. And so this is a pure imaginary number. So it's still a type of a complex number, but it's just pure imaginary. There's no real part to it because the real part is 0. All right, so now we're going to be doing some different operations with complex numbers. And these should be really familiar because these are all similar to what we do with variables. So first thing we're going to do is add and subtract them. So kind of similar to variables, except this time we have imaginary parts and real parts. First thing we're going to do is combine the real parts and combine the imaginary parts. So I like to think of this just like combining like terms. Okay, so some examples here. So we're told to simplify. And number 1, we're given in parentheses 4 plus 6i, so that's our first complex number, plus -3 plus 5i. So out of our 3 categories over here, these are both non-real complex numbers. And so what we're going to do, we're not going to get rid of these parentheses. That's just saying we have one complex number and another complex number. We are adding them together. So let's go ahead and combine like terms. So we have the 4 plus -3 is 1. 6i plus 5i, just like variables, we get 11i. And that is all we have to do for these, just combine like terms and we're done. Let's try a few more. This next one, we're given, this one's a little bit longer, 5 minus I plus -3 plus 3i plus 6 minus 4i. Now, when you have one like this, make sure your pluses and minuses are the same. So we have a plus and a plus. So that's nice. We're just combining all 3 of these together. And if you want to do this in 2 steps, so like add these 2 and then add the third one, you can. I like to do this in just 1 step though. So I'm going to have 5 plus a -3, that gives us 2. And then 2 plus 6 is 8. Then we have -i, so think of this as a -1i. Let me make that a little better. So -1 plus 3 is 2, and then 2 minus 4 is -2i. Again, just combine the like terms. Now, what if we have subtraction? So what if we have something like 7 plus 3i minus 4 plus 3i? Now, what you want to do for this one, if you remember, I like to add the opposite. So we're going to change this to add the opposite. That way we don't have to deal with that minus sign in the front. We can just combine like terms like we just did. So 7 minus 4, or 7 plus -4, that gives us 3. And then 3i plus -3i, those are opposites. So just like regular numbers, just like variables, those guys will actually just cancel out. So we get a real number as our solution here. Last one before we try multiplying. If we have -1 plus 12i minus -1 minus I. Now again, it's subtraction, so I'm going to change it to adding the opposite. And now let's combine. So we have -1 plus 1. Well, those are opposites, so the real part cancels out. And now we have 12i plus 1i. If you forget that one, just write it in. 12 plus 1 is 13i. So this one is just a pure imaginary number. All right, now let's go ahead and look at multiplying complex numbers. And so one thing I want you to remember, and I'm going to put it in red, I'm going to put stars around it, because like I've said before, you need to have this down. I squared is equal to -1. So we're going to use this a lot when we're multiplying. So let's go ahead and look at some examples. And again, works really similarly to variables. So if you have like an I times an I, you get an I squared. Exponent rules still apply here. Whoops. Multiply. Number 1, we're given 6i times 5i. Now, just like variables, you're going to multiply the coefficients. So 6 times 5 is 30. And then I times I is I squared. Now, I squared we know is -1. Always replace I squared with -1. So we have 30 times -1, which is -30. Hopefully that one's not too bad. That's just a single term. Let's try another single term before we get into some distributing. This one we're given -2i times -4i. So -2 times -2 is 8. I'm going to go ahead and, I'm going to change this -4i to a +4i. Because I want to show you something specific that happens if we have a negative times a positive. Okay, so starting over here, -2i times 4i. -2 times 4 is -8. I times I is I squared. And then same thing, let's replace this I squared with an, -1. So we have -8 times -1, which gives us a +8. All right, let's try another one. This one we're going to be distributing. We're given 6i times 4 plus 3i. Now, just like with variables, we're going to distribute this 6i in. So 6i times 4, we're going to multiply the numbers. So we get 24, and then we have a single I, plus 6 times 3 is 18. I times I is I squared. Now, with ones like this, with a 24i, if you have a single I, there is nothing you can do with that one. So we're going to leave that alone. But 18i squared, this I squared is a -1. So we're going to have 18 times -1. Now we have 24i. 18 times -1 is -18. Now this is technically correct. If they want you to write this in what we call kind of like the standard form for complex numbers, the real part goes first, so -18, and then plus 24i. So if they are picky about how they want their answers in MyMathLab, this would be like the standard form, and that's a plus bi. So they might just say put it in a plus bi form. I'm not too sure, but either one would be correct if they don't specify. All right, number 4, we're given 6 minus 4i times 2 plus 4i. Now, if we go ahead and FOIL, just like when we have variables, we're going to do 6 times 2, which is 12. 6 times 4i is 24i, so plus 24i. Inside, -4i times 2 is -8i. And last, -4 times 4 is -16. And then I times I is I squared. Now, a couple things we can do here. We can combine our like terms in the middle. So we're going to have a 12 plus 24 minus 8 is going to give us 16. So 16i. I can also change this I squared to a -1. So we're going to have -16 times -1. Now, if I go ahead and multiply that, we have 12 plus 16i. -16 times -1 is a positive 16. Now there's one last thing, we can combine these real numbers. So we get 28 plus 16i. Make sure you fully combine all of your like terms. Number 5, we're given 5 plus 2i squared. Now, same thing that has applied to all of the polynomials we've seen like this. We cannot just square each of these terms. So if you remember, what we have to do is think about what it means to square something. That means we multiply by itself. So we're going to have 5 plus 2i times 5 plus 2i. Now, if we go ahead and FOIL this out, 5 times 5 is 25. 5 times a 2i is a positive 10i. The inside terms, 2i times 5, that's again 10i. And lastly, 2i times 2i, 2 times 2 is a positive 4. I times I is I squared. Now let's go ahead and combine and simplify. So I can combine the 10 i's in the middle. So we have 25 plus 20i plus 4 times -1 because of that I squared. Now I'll go ahead and multiply 4 times -1. So we have 25 plus 20i. And now 4 times -1 is -4. Combine those real numbers, and we get 21 plus 20i. All right, let's go ahead and try one more of these. These are a special type. I'm actually going to put this on the next page so that I can make some notes on this. So number 6, we're given 3 minus 2i and 3 plus 2i. Now, if you remember back to section 10.5, when we were rationalizing denominators, we had something called conjugates. Now, that is exactly what these are. These are conjugates. And so I'll write some more notes on those after we do this problem. We'll kind of take note of what happens. But if you remember with conjugates, when we multiplied them, when we had radicals, it got rid of the square roots. So let's see what happens in this one. So we're going to FOIL. So 3 times 3 is 9. 3 times 2i is a positive 6i. Negative 2i times 3 is negative 6i. And negative 2i times 2i, negative 2 times 2 is negative 4. I times I is I squared. Now let's combine and simplify. So 6i minus 6i, those guys cancel out, which is exactly what happened when we worked with radicals. The middle terms cancel. So we have 9 minus 4 times negative 1. Now 4 times negative 1, or negative 4 times negative 1 is a positive 4. So 9 plus 4, which is 13. Now notice how we just ended up with a real number here because our imaginary parts canceled out. So that's what happens when we have conjugates. So if we look at, and I'm going to call them complex conjugates because they are a specific type. We're working with complex numbers. So this is what we have if we have something of the form a plus bi and a minus bi. So the same terms, but the opposite sign in the middle. And now when we multiply conjugates together, so a plus bi times a minus bi, what we get, if I were to go through and FOIL this out, cancel out our terms, I'm going to skip through all that work and just show you that we're going to get a squared plus b squared. Now, if we look back at what we had here, a was 3. B is 2. It's always the positive version because you have a positive and a negative. And a squared plus b squared. Well, a squared is 3 squared. B squared is 2 squared. 3 squared is 9. Plus 2 squared is 4. And you do get that 13. So this is kind of a shortcut if you notice that you have conjugates. Most of the time, I'll just go through and multiply it all out anyway. But there is a question on the homework that asks what happens when you get, when you multiply conjugates together. So the nice thing here is that this eliminates I, so we don't have to work with imaginary numbers. And this number that you get is always positive. And so the reason why that is because something squared is always positive, and we have a positive plus a positive, which gives us another positive. So it's always positive and real. All right, that's it for section 10.7 and chapter 10. So next we'll be looking at chapter 11. We're going to be looking at solving quadratic equations, which we've seen before. But now we're going to see some other methods when you can't factor. So that'll be our next and last chapter.